So for example, one, our mean is 104.1. Median is 102. Multimodal, so you can see 50, 95, 102, 160, and then mid-range is 105. So yeah, exactly. And you can kind of see, like you said, yeah, multimodal, just because we have so many values in there, it's kind of all over the place. But look at these values. I mean, they're not really that far apart from each other, right? I mean, you are within about 2 to 3 units of each of these values. So I think this is a pretty equally spaced out data values, I would say, since you know, 3 of your calculations are so close to one another. Okay, and then number 13, can we calculate a mid-range there? I guess we could. What could we do for the mid-range calculation for number 13? What would be our lowest value in this case? Yeah, I would take that lowest boundary. And then our largest one, 96.5, add those, divide by 2, and what would you end up with? 72. And can you tell me what our other values were for this data set? What had our mean come out to be for this guy?
72 was mid-range. The lowest class was 68.5 to 75.
Yeah, because that was the one with the 13 frequency. Okay, so again, what can we say in terms of our 4 different measurements of central tendencies here? 72 for the mid-range, 72.6 for the mean, 72 for the mode, and then your modal class is around those numbers, right? 68.5 to 75.5. Yeah, again, pretty representative. Not any one number is not like, you know, standing out from the others, because again, your data was pretty evenly spread out. So if you notice this table here, so we've got 13 in the middle, right? And then we're on either side, we've got 9 and 8. So again, those frequencies are pretty close to each other. And then we've got 3 and 2 at the smaller end. So again, you can see this set is pretty evenly spaced out again, and that shows you in your central tendency calculations here. Okay, so now the next part about these calculations we want to talk about is the weighted mean. So when you are talking about the weighted mean, in this case, you know, we are talking about where your data sets would not be equally represented. So looking at an example here, they're saying finding the average cost of a gallon of gasoline for 3 taxis. So they're saying suppose that the drivers buy gasoline at 3 different service stations, and they're paying $3.22 at one, $3.53 at the other, $3.63 at the third one. And then of course we want to find out what that average price would be, I guess. So obviously you can see we're just taking those $3 amounts, dividing it by 3. And we're saying, well, approximately on an average, they paid $3.46 per gallon of gas, right? Does that give us an accurate calculation? It doesn't, right? Because we're not taking into consideration, well, how many gallons of gas did they get, right? Did they fill up their taxis? Did they, you know, just do, you know, okay, I'm going to do a $10, and how much ever I get in that $10, that's what I'm going to keep, that kind of thing. So it really makes a difference. So you have to actually take the number of gallons into consideration, and that's where, instead of just taking a regular mean, we do this weighted mean, where you actually have to take how many gallons they pumped, multiply that with the price for the gasoline, and then actually calculate your average. So if you look at the formula for the weighted mean, so they're saying you start by taking your variable x, multiplying each value by its corresponding weight, and then dividing the sum by the sum of your weights. to get that weighted mean idea here. So they're using W to show the weight, and X would actually be the variable. So in our gasoline example, the price per gallon would be your X value, and then how many gallons we filled would be our W, our weight. Okay, so in this case, we're talking about a grade point average computation. So, again, depending on what course you are taking and what credit hours it is, it makes a big difference on how your GPA is calculated. So this class is 3 credit hours, but if you take like a biology, chemistry course, they are normally 4 credit hours or more, right? Because they also have the lab as part of it. If you take our college algebra course, then because the way that course is, that's actually a 4 credit hour course, right? So it's going to make a difference on how your GPA is calculated, or for any student. So here they're telling us a student received A in English Comp, which was 3 credit hours, C in Intro to Psychology, which is also 3 credit hours, B in Biology, which is 4, and a D in Physical Education, which was only 2 credit hours. So, of course, we use A as 4 grade points, B as 3, C as 2, D as 1, and then F, of course, would be a 0. So then based on that, you can see based on their grade, we assign those points, right? And then taking your number of credit hours with the points, multiply them, and then divide by your total number of credits they took, okay? So if we try and do a similar example to this, and let me see if I can find one here. Okay, let's look at number 23 from our textbook. Okay, they're asking us to find the weighted mean price of 3 models of automobiles. So the number and price of each model are shown. So take a minute, look through the problem, and then decide which are going to be your X values and which one is going to be your weight, your W value. Okay. So for our weighted mean, it's X bar equals your summation of the weight times X divided by the summation of the weight. So what are you going to put on the numerator?
Eight times 10,000
Mm-hmm.
plus 10 times 12,000.
Very good. All right, now that was actually the easy part. What will be on the denominator? Yeah, it's actually going to be the number of vehicles sold, right? So it's kind of like that same example like we looked at with the gallons and the price per gallon. So how many vehicles are they selling? And that vehicle, that model was priced at 10,000, right? That model was priced at 12,000 or 8,000. So 8 plus 10 plus 12 will become your denominator. So let's see what those numbers come out to be. So what's my numerator going to be? Does anybody calculate that? Just read out the digits. Okay, does anybody know how to read out that number? Yeah. You know it in Spanish? How would you say that in Spanish? You don't know? Okay. Oh, that's all right. And what's our denominator? 30. All righty. So what does that weighted mean look like?
5,866.
Okay, and since this is dollar amount, what's our change?
67.
67 cents. Very good. So this is actually going to be your weighted mean. Did everybody get that number? Okay. Let me see if you guys can do. Nope. Did everybody get that? I'm going to clear my screen. All right. How about I give you guys, I don't know, a minute, 2 minutes? Let me see what you guys come up with.